Okay, so good evening, everyone. On behalf of CFAL Astro Club and the Coastal Astronomy Group, I welcome you all to this session. Today, for the talk on Indian achievements in space, we have the resource person, Dr. Gourav Bannerjee. He is an observational astronomer and postdoctoral researcher in the Indian Institute of Astrophysics. He is currently stationed in the Vainu Observatory, Kavlur. His research focuses on a special type of stars. He holds a MPhil and a PhD in astrophysics from Christ University, Bangalore, and an MTech in astronomy and space engineering from Manipal Academy of Higher Education. Dr. Banerjee is a life member of International Astronomical Union, the Astronomical Society of India, and the Indian Physical Society. He is actively engaged in astronomy outreach for over a decade, and he has delivered some 500 plus popular astronomy talks nationwide, and he has authored two books. One is titled Becoming an Astronomer. That's a first guide for the students here in India to pursue astronomy. And the other is titled Mars, a celestial shows topper, which explores how the study of Mars has advanced the science and technology over 2000 years. Both the books are available on Amazon. Now I hand over the space to Gaurav Banerjee, sir.
Yeah. Hello and good evening, everyone. And good evening to CFFL. Good evening to Shinaji for arranging this. So I would like to share my screen. I'm just switching off my video. Yeah, please give me a minute. I hope I am visible. So is the screen visible?
Yes, it is.
Okay, and I hope I'm audible also.
Clearly.
Okay. So we can start today. So good evening, everyone, and all the participants, all the students, and on behalf of Indian Institute of Astrophysics, I welcome all of you. So yes, as we know that tomorrow, 23rd August, is the National Space Day that has been started since previous year for a particular reason, because 2 years ago, on 23rd August 2023, we know that Chandrayaan-3, our third mission to moon, that landed safely on moon, and we became the fourth nation in the world to safely land on moon with and became successful in that mission. So to commemorate this 23rd August every year and celebrate our India's triumph of space, government of India, previous year they decided that 23rd August every year should be celebrated as National Space Day. Likewise, we also have National Science Day, which is celebrated on 28th of February every year. So National Space Day will be celebrated from 2024 onwards on every year 23rd August. So we are standing on very brink of celebrating the second National Space Day tomorrow. And on behalf of for commemorating, for celebration of this particular day, this is the talk which has been provided or which has been organized by the team. I thank the team members, all the organizing committee members, for giving me an opportunity to deliver this talk. Naturally, I thought that on this particular day, let us have a glimpse. Let us talk about how India became. We have sent our successful mission to Mars, to Moon, but how this all happened. India's journey to space started almost from zero. Basically, not even from zero. I can say that it started from minus. So it started from a small village, which was a fishing village, which is still now a fishing village. And from a fishing village, we have reached Mars orbit. We have soft landed our spacecraft on moon. How this all happened, India's journey to space, is basically an incredible true story, a thrilling adventure story, and every aspect of this story is real, is true. So I wanted to discuss this aspect with you all. I feel that whenever I read about this story, India's journey to space. I myself feel motivated and I wanted to share that motivation with all of you today. So, my friends, before starting this, how India started its space technology and space journey, we have to go back very early, towards very early days, maybe in unwritten historical period, very ancient days when people were like this. We were very primitive. And why people suddenly started watching the sky, why interest in astronomy was started, specifically we don't know, but we suspect, we expect that most probably it was due to the natural curiosity which human beings generally possess. Due to this natural curiosity of human beings, they started watching the night sky, watching even the morning sky when the sun is there. So this sky watching started very long ago in prehistoric times, and that has nothing to do with some special event, might be that has something to do with a special property of human beings, that is natural curiosity. Now, if we go back to those days like this, which is maybe thousands of years ago, maybe 1 lakh years ago, you see primitive people who were watching the sky may not be understanding what these objects are. But during those times also, definitely, some people were there who were intellectuals, who were definitely intellectuals, and some of them, by observing, by noticing the night sky and the morning sky years after years, days after days, and months after months, they realized, some of them definitely realized that something is going to happen. What is going to happen? If we see that same sky for years after years, months after months, some people were able to realize that we can actually take the help of these sky objects to make the first map, to make our calendars, to also understand when to do cultivation, how to do navigation, how to go from one place to another without being lost in jungles or unwanted places. So this night sky started serving as the first guide to civilization, both in the help of today we have compass, we have GPS, we have calendars, very advanced calendars, watches. But think about a day thousands of years ago. The night sky was the only guide for civilization. Overall civilization of humanity has dependent on astronomy and astrophysics, has dependent on the knowledge of astronomy and space science right from the beginning of the first awakening of human beings. So the first calendar, the first map, the first clock, the first compass, the first navigational system, the first proper scientific ways how to cultivate a land, how to do agriculture, all this knowledge, all this predominant knowledge came by observing the night sky. How? I can give an example here. If we see this night sky, this is the night sky from a village. Now, we will see there are so many dots. Presently, we know most of these dots. Basically, in this picture, all the dots are stars. Now, definitely, if any one of us is observing this, not watching, we are observing this picture carefully, we might be able to understand that there are certain stars or certain dots which are brighter than the neighboring ones. Now, if you go on observing this night sky day after day, night after night, months after months, you will see that by observing the night sky, we can make some particular patterns by joining some particular bright dots or bright stars in the sky. So we can do that. And if we do that, then those patterns like this is how the winter sky is divided. There are so many stars in the winter sky, and primitive people, ancient people, in almost every ancient civilization, they have used this night sky to make imaginary patterns like this. And these imaginary patterns, presently we call them as constellations. Using these imaginary patterns, now the patterns might look like a human being, the patterns might look alike of any particular animal, any particular item, day-to-day use item. Now, these particular patterns became the first guide to the human beings to make a calendar. The sky was the first calendar for human beings. if we can see this Orion, and this particular constellation is in a night, rising in a night, rising during the evening time, then what we can understand is winter is coming. If we see this particular Orion rising at late night, same Orion. So if you don't sleep today or tomorrow, or maybe any day during this rainy season, August, September, and look at the sky for late night, you will see Orion is rising at late night, after 1 o'clock, after 2 o'clock. Now, if Orion, the same constellation, is rising at late night, then we can understand in our northern hemisphere, rainy season is going on. So this is a very basic example which I am giving. What I want to say, what I want to translate is basically by watching these night sky patterns, these are imaginary patterns, and how they move in the sky, how they are rising and setting at what particular, during what particular time of the year, or what particular time, people were able to understand what is the exact time from where they are observing the sky, and what time, what particular season is going to come. So this helped them for navigation, this helped them for agriculture, this helped them for cultivation of proper crops during proper time. Now, these same patterns, there are presently, likewise, the whole sky is divided into 88 such patterns, which we call as constellations. And we astronomy people or astronomers, we actually follow the norms and regulations, worldwide norms and regulations set by this particular organization known as International Astronomical Union. So in 1928, they actually divided the sky. They actually made this norm that the whole sky will be divided into 88 such constellations. The most famous among all those constellations I have shown here, definitely it is the Orion, the imaginary hunter which is in the sky. But my friends, we have to understand, I am constituently telling you that these are imaginary figures. This has nothing to do with reality. So these imaginary figures help us to identify the sky, to identify the night sky. And till now, people like us take the help of these constellations to understand the time, to understand seasons. These are constellations, these are the best clocks, the best calendars in the what we can ever imagine. There can be some difficulties, some technological glitches can happen in technological advancements, but the night sky will never have any problem. So this is how astronomy actually began. Gradually it began. It was not known as astronomy or astrophysics during those primitive days, but human beings, most probably we can understand by now, for their own need for survival in this harsh world during those days, they had to understand how the sky is working. They had to understand whatever possible about space and about astronomy. However, we had to wait a long time, because just by observing the night sky through your naked eyes, you can up to a certain level get some knowledge, but for getting proper knowledge to understand how these objects are behaving, the physics and the properties of these celestial objects, we had to wait for so long time. Now, during those times, when I'm talking about these days, very old days, during the ancient times, if we go back 1500, 2000 years ago, in our Indian soil, what was going on? Weren't Indians practicing or doing astronomy? Definitely, yes. In ancient times also, practice of astronomy, practice of watching the sky, studying the sky was there. But mostly this practice was concentrated on understanding the night sky patterns, the constellations, the zodiacal signs, and to make ritualistic, to make the timings for the rituals, different festivals, also to understand how we can grow crops, how we can cultivate all these things. So some of the great astronomers of ancient India were definitely Lagat, Aryabhatta, Brahmagupta, Varahamihir. But among them, definitely this person, Aryabhatta, I presume every one of you know this name. Aryabhatta can be considered as the first astronomer of India, of ancient Indian soil, who not only focused on understanding or making or studying astronomy just for the purpose of setting calendars or preparing logarithmic tables or proper timings for, say, festivals and rituals. he went much more beyond that. You can see here that he was not only studying the sky for the purpose of human knowledge development or human some ritualistic help or some calendric help or some agricultural help. He was also studying the sky. He studied the sky, the night sky, just to know, just for gaining knowledge more and more about this universe, about the celestial objects. You can understand, you can see here that he was the first person who actually measured almost very, very correctly what is the rotation period of Earth. He was also the first person in the world who explained properly why lunar and solar eclipses do happen. And how we know about these things? Because a book written by him, Aryabhatyam, till now exists, and all these things are written there. So he was a person who came during the time of around 476, 470 to 500 AD. So around 1500 years ago, he was there, and that book till now exists. During almost after another few hundred years, during around 7th to 12th century, there was also another place in Kerala. Basically, Kerala became the epitome of astronomy studies during those period. So this Kerala school of astronomy also thrived for around 500 years. And so many good, proper, wonderful astronomers were produced from that school also. Most probably this Kerala school of astronomy is was the longest surviving astronomy institute or school till now in the world, because this school has gone producing astronomers and practicing astronomy for more than 400 years. So one of the greatest astronomer produced from this Kerala School of Astronomy is definitely Nilakanta Somyaji. I am not going to details. You can go through and search about these people. Now, this is what gradually astronomy was progressing like this. However, for making a proper advancement in astronomy and our understanding about physics and science, we had to wait for so many other long time. But before that, I would also like to highlight, we can also, in our own India, we can also get the glimpse of some of the finest old astronomical instruments, the machinery, the rock-built instruments, which were used by astronomy people or people practicing astronomy during the time before the invention of the telescope. So you see this, there was a king, Swai Jai Singh in Rajasthan, who built 5 places, 5 basically sky observing observatories during his reign in different places. One is in Jaipur, the finest protected old astronomical observatory in India. This is known as Jantar Mantar. And I am sure that you all have heard about this instrument known as sundial, an instrument by which we can measure time. We can check what is the time when sun is there in the morning time. So what you can see here is this particular sundial, which is made by rock. It is inside Jantar Mantar. This is still now the world's largest working sundial. You can see sun's light is falling here, and by measuring how the shadow is falling, in which area shadow is falling, you can actually precisely tell the time within every 2 seconds. So anyone who can visit, who wants to visit Jaipur, please observe, please go to this Jantar Mantar. This is a marvel of ancient Indian astronomy in India. All the instruments made by him, there are 12 instruments, astronomical instruments, all are working perfectly fine right from those 1730s. But these type of instruments, my friends, we have to understand these type of instruments can help us in studying astronomy or knowing about the sky up to a certain limit. We had to wait for a long time to cross that limit. And that limit was broken when telescopes were invented. We have to remember that Galileo Galilei in 1609 was not the person who discovered or invented telescope. He was the person who first actually watched the sky using a telescope. So that is why basically he is important, or he is definitely important. And after watching the sky using his own telescopes, what he understood, what he saw, actually gave birth to modern science, to modern astronomy. It was in 1609. So from 1609 onwards, when telescopes came into the hands of humanity, science and modern astronomy was born, and almost all types of wrong views of humanity regarding sky, regarding science, were gradually fallen down. So from 1609 onwards, we can actually say the year when Galileo first pointed his first telescope towards the sky. From that time onwards, basically, modern science and modern astronomy took birth, and our view about the universe changed forever. From that day onwards, we have come to a very long distance. Now we have our space telescopes. We have Hubble Space Telescope, a fantastic instrument, one of the greatest instrument ever built by humanity is this particular Hubble Space Telescope, which is in space, and working for more than 30 years now. Very recently, we have also launched another more fantastic instrument, that is James Webb Space Telescope. So can we imagine, we can just try to imagine those days 400 years ago, little more than 400 years ago, when first telescope was used for watching the sky. Within 400 years, a huge drastic development of science technology has taken place. And I can assure you, my friends, if you read thoroughly about these things, you will understand. I can definitely assure you that our humanity's progress in science, technology, and almost every aspect, every subject which you can name, depended on the advancement of the knowledge of astronomy and space science. Within 400 years, as astronomy and space science knowledge has increased, if you read the history of scientific development, you will see how the knowledge gained by studying astronomy and space science has rapidly helped us to understand more and more about how nature works, how physics and chemistry works, how technology can be used for the development of human beings. That I am not going to that particular detailed story, but what I wanted to say is, so this is the time when we are standing now. We are having space telescopes in space now. And that has happened within the past around few hundred years. What was the condition of India? We were under the British rule. Definitely, it was a very difficult time for us. Now, what we were doing during those days, after those machinery instruments came, what we were doing. Before going to that, let us come to this picture, which shows you, okay, if we are having top class observatory type of telescopes in space, we also have top class telescopes which are located in ground based facilities in various remote places of the world. This particular last picture is an artistic impression. This is the 30-meter telescope. It is going to be the largest telescope in the world in future. But these three are real. These are definitely placed in different places of the world. Now, how do we actually understand the details about astronomy and different astronomical phenomena, the properties of so long distant stars, galaxies, cosmological events, is by these type of telescopes. The observatories, where these type of sophisticated telescopes having sophisticated instruments are there, huge telescopes, huge systems, and definitely using our developed science and technological instruments, sophistication, and pioneering space-based telescopes. Either we can send space-based telescopes, and whatever possible, using ground-based facilities, we use this type of professional telescopes. Definitely by any simple amateur level telescope, or the telescopes which I was showing here, the telescopes which were used by Galileo. Nowadays also we use these type of telescopes for sky watching, for getting fun, and you can understand by these small telescopes, we will not be able to reveal the secrets of the universe in its full glory. So for that purpose, we either need our instruments, our telescopes to move away from our Earth's atmosphere to go to space, and otherwise else, we have to make wonderfully sophisticated telescopes along with instruments in our Earth. These are known as professional telescopes and ground-based facilities. So these ground-based facilities will all be hosted in what we call as astronomical observatories. Now, definitely, if I give a glimpse of some observatories in India at present and astronomy in modern India, then we can definitely say without any doubt that India presently is one of the premier research or premier countries in astronomy and space science research. You see, there are so many top class, world class astronomy research institutes in India. Out of these institutes, there are 4 particular institutes which are absolutely dedicated for astronomy research. So you can see here this IIA, Indian Institute of Astrophysics, whose headquarters is Bangalore, IUCA, another great institute, Inter-University Center for Astronomy and Astrophysics. It is at Pune. Then you see here, there is the peak mountain. It is at Nainital, Uttarakhand, Aries, Aryabhatta Research Institute of Observational Sciences. And the down picture you see here, it is written NCRA. It is also at Pune, National Center for Radio Astrophysics. Likewise, we have 4 particularly dedicated top-class research institutes dedicated for astronomy research. Apart from that, we have several other top-notch institutes across all over India, almost in all big cities and smaller cities, where astronomy research is done very vividly. So you see here, like one I have shown here, SN Bose National Center for Basic Sciences. This is in Calcutta. The last picture, some of you might recognize, this is the famous Indian Institute of Science, IISc Bangalore. And apart from this kind of institutes, definitely IITs, NITs, more and more IITs, NITs, separate private and government universities, they are also coming up with astronomy departments or astronomy courses. That is rapidly increasing in India now, because at present, India is standing in a golden age of astronomy. India is definitely a major player of space science and astronomy in the world. This particular institute, if you see, this is also a very famous institute, IIST, Indian Institute of Space Science and Technology. This is the only university in Asia which is absolutely dedicated for space technology. So this is in Trivandrum, Kerala. So likewise, if I tell the present story, yes, we are one of the major astronomy and space leaders of the world. I am coming from Indian Institute of Astrophysics, as I have told that in the area of optical astronomy, if you want to work, I presume that IIA is definitely not only leading India, but it is one of the most premier institute in whole of Asia, especially focusing on optical astronomy research. So we have a network of particularly different laboratories and basically 4 astronomical observatories which are located in different places. So you see, I am speaking to you from a place called Kavalur, Tamil Nadu, full of jungle. So this is where I am located now, Vainu Bappu Observatory. Then we also have one of the oldest solar observatories in the world, which is at Kodaikanal, Tamil Nadu, Kodaikanal Solar Observatory. We have a radio observatory near Bangalore, which is known as Gauri Bidanur Radio Observatory. And definitely we have another extremely good observatory, optical astronomy observatory, Indian Astronomical Observatory, which is at a place called Hanle, at a remote place in Ladakh in Jammu and Kashmir. So since I am situated here, this is the place where I am situated now. And presently I am talking to you from a place somewhere nearby here. So this is the place where our guest house is located. You cannot see because there are trees. So this is the Vainu Bappu Observatory, which is regarded as the telescope town of India. Definitely, being a part of this observatory, I extend my welcome to all of you, to any institute, any organization. If you want to visit this observatory, please do visit. You can come. You can definitely visit this observatory. You have to write a mail, go to the observatory, go to IIA website, go to the observatory website. You will get the mail ID for the outreach team of this observatory. You can write a mail to the outreach team and gradually fix a plan when you can visit this observatory. If you want to know more about this observatory's history, you can go to this particular article and read it. So this is a wonderful place for watching the sky. Now, these things, till now, whatever I have spoken for around 30 minutes now, These things presently we are having, and I am claiming that we are at one of the topmost countries in the world, specifically focusing on astronomy and space science. Leaving apart the astronomy part, if I only talk about the space science part, since tomorrow is National Space Day, in space science also we are one of the leaders. But how it all started, it was not so easy, my friends. It, it started because of some need. When our India became independent, there were great visionaries. Some of them were Jawaharlal Nehru. One of them was Meghnad Saha, who basically understood the need of space science and why any country who wants to develop in every aspect has to develop a wonderful, fantastic space program. So in 1945, Jawaharlal Nehru actually made an advanced space committee that whenever India will soon become free, after that, the development of astronomy and space science has to take place very fast. Any country you can think of, any country which is a very developed country in the world, is very, very good in space science. So that need was understood, and that's Astronomy and Space Committee was headed by the chairman, Dr. Meghnad Saha, one of the most brilliant astrophysicists which India has produced. And after our India got free, that time also, we were in a very difficult stage because it was huge poverty. We almost had nothing in our country. Everything was looted by British. But this need was understood, need for space science. There are so much, if almost development in almost every aspect will depend on space science. So naturally, there were some people apart from Nehru and also Vallabhbhai Patel, Nehru, then Meghnad Saha, some people were there who understood this need more, that we have to develop a space program as early as possible. Some of them were Homi Bhabha, Vikram Sarabhai, the father of space technology in India, MGK Menon, but they wanted to develop something, space technology. However, how to develop that? Before going to this story, I would like to come back to history again. If you go to ancient history, you will see the first rockets. The first rockets were invented by Chinese people around 800 years ago. And this is how the first rockets look like. The simple firecracker kind of rockets where bamboo tubes were packed by gunpowder, and this was used as rockets. However, one amazing fact about India is this. All of you are belonging from Karnataka, Bangalore specifically, but all of you are belonging from Karnataka. It should be a pride for all Kannada people that the first usage of rocket in the history of humanity was done by somebody known as Tipu Sultan from Karnataka during the battle against the British during 1792 and 1799. Tipu Sultan and his guardian Hyder Ali were the first people in the world who actually used rockets, and that actually raptured the British defense. You can still see Tipu Sultan's rockets if you go to Srirangapatnam, his place of reign. You can go to the museum and you can see the first rockets which were used by human beings, but the first developed rockets used for some purpose in the world. So this is a huge history. It was 1790s, but for development purpose, rockets were used when? It was a Russian during 1890s and 1900s, early 1900, when this person, Konstantin Tsiolkovsky, he is regarded as the father of space science or father of space travel. He was the person who derived properly the mathematical equations and principles, the basic mathematical equations for rocketry, for development of a rocket. And if I come another 25, 26 years, you see, in 1926, just 99 years ago, the first rocket was launched. Proper liquid fuel first rocket was launched. This was from America by Robert Goddard. And again, we had to wait. We had to wait for the development of technology, science, and ultimately in 1957, the first object, the first artificial object or satellite which was launched successfully to space. We know it is Sputnik 1. Then 1961 came when a first human being went to space, Yuri Gagarin. And ultimately in 1969, if we come, we see that human beings also walked on moon and came back safely to Earth. Now, during this time, I am talking about 1969, and our India was just a newborn country having so many problems. What India was doing then? At that time, what India was doing? Basically, we didn't have any funding. There was no proper office for having a space program. There was no laboratory. There was even dearth of good food during the early 1950s. No proper funding was there. But there were, as I have mentioned, there were some people who had a great dream for India. So apart from Nehru, Vallabhbhai Patel, Meghnad Saha, who were the forefathers, there was this person, Vikram Sarabhai, the father of space technology, M.G.K. Menon, and some people, and definitely APJ Abdul Kalam, some people like them came out, and in 1963, they launched a rocket from a small fishing village in Kerala. And that actually started India's space program. That is a long journey. And as I have claimed, now India is one of the leaders in space research. To give a glimpse of that journey, let us come to this point. How this space program started is, it started basically from minus. They had nothing. But these great people, great visionary people like them, they had a huge dream for India, and they worked not only hard, maybe the hardest possible work they have done to make our space program active and successful. So in 1962, basically one committee was made, which we call as INCOSPER. It was under Department of Atomic Energy, and NASA actually signed an agreement with this particular committee of India. The NASA told, okay, we will give some rockets made in India. You people just launch those rockets. So for that purpose, in this small, there is a village known as Thumba near to Trivandrum, which is a small fishing village. So in that particular village of Kerala, this Thumba Equatorial Rocket Launching Station was established. And within 1 year, the first sounding rocket was launched from India. So it was a great, great achievement. It was not easy. There were no roads, there were no proper food, there was no office, no laboratory to make this rocket. To even launch this rocket, we need so many things. We need a launch pad. Where was it? Nothing was there. But within 1 year, these people successfully launched the first rocket. And they understood that we should not only go on launching rockets taken from other countries like NASA or America. That is good that they have helped us during initial days. But we have to make our own rockets. And within these 4 years, they made their own rocket. India launched its first own successfully made indigenously made sounding rocket, Rohini 75. That was in 1967. And now you remember 1969, the time when basically the 28th July 1969, when already NASA, when already US has sent properly human beings to moon and they came back safely. After 1 month of that, in 15th August 1969, the so-called ISRO, Indian Space Research Organization, was established. So basically, that's why I have shown those pictures. We were running very late. We were a newborn country, extremely newborn country, having so many deeper troubles, so many problems. But still, some of these great visionary people were able to see a dream, a huge dream, and successfully they were able to create history and make it success, that we have to establish a proper space research program. So developing or actually making this ISRO, founding this ISRO was not an easy journey. Let me go to those days. If I now, instead of talking, show you some pictures, you will understand how difficult it was. You see, this is that Thumba village from when in 1963 the first rocket was launched. This rocket was given to India by NASA. And as I was telling my friends, can any one of you guess, see the village during that day, those days, how this rocket will be launched? We need a proper rocket launching place. We need proper laboratory, proper office to launch this rocket. Nothing is there in this village. So how ISRO was formed, how those people were working, where they were developing this rocket, necessary other parts and launching parts. That story is really fascinating, my friends. You see in this figure, there is a church. Till now, this church is there in Thumba village. So basically, there was no proper place where an office can be established so that a rocket components can be assembled and the launching can be done. So what these people did, Vikram Sarabhai and those senior visionary people, they went to this church and spoke to the bishop of this church that we would like to make a rocket and we would like to launch a rocket, and that will ultimately help in the development of space science program for India, which will be a huge help for the development of India. So we need we need your church, at least one room we need inside your church, and that room we want to convert it, instead of praying to God, we will convert that room for making our first rocket launching office. The whole village, all the villagers were consulted, and the church committee, the bishop agreed that instead of praying to God, that particular church room will be given to those young, excellent scientists so that our space program can start. And the first birth of ISRO took place inside this church in 1969. The first office of ISRO was inside this church. There is a room. And at present, this church, the St. Mary Magdalene Church, it is converted as the India's National Space Museum. Any one of you, if you visit Trivandrum, nearby Trivandrum, Thumba village, please see this place. Any astronomy or space science enthusiast, I can guarantee you, you will be getting huge motivation if you see that our space program started from a church. We had no office at all. Not a single country you will see in the history who has started their space program from minus or zero, and within 50 years has reached, soft landed on moon and sent successfully a Mars mission. Not a single country has been able to do this. So now if I go to those days pictures, you see I have told there were no proper roads. How will you carry your rocket components to that office, to that church? This is how the rocket components were carried. And these were not simple people. This person is Vikram Sarabhai, the right-hand person. The left-hand person is APJ Abdul Kalam, the young APJ Abdul Kalam. I think by watching these pictures only, any human being who is studying even in schools can gain an understanding why we worship these people as God. They have given lot to our country. So this is the room where you see young Abdul Kalam, then Vikram Sarabhai. This is the room inside the church where the development and the assembly of that rockets are going on. And this continued. Now, not only that year only, for around 20 years, the first phase of ISRO, rocket making, rocket launching, rocket component carrying, transportation were carried out like that, either by bicycles or by bullock carts. You see, these were the early days of ISRO. A bullock cart carrying one of the satellite of ISRO. So this is how our ISRO started. And that satellite, even in 1981, the Apple satellite was carried through bullock carts. So if during those days, if you would have traveled to Thumba, this type of sight would have been very common. Rocket parts being carried by a herd of bullock carts. Can any one of you tell me any country for whom space technology has started like this? Bullock carts carrying, or bicycle, human beings carrying rocket parts, making rockets and successfully launching it. This is how we started our rocket journey, our space journey. It is a long story. I can go on continuing, but well, I will now, instead of that, let me concentrate after that what we have achieved a little bit. So yes, Aryabhatta, on the name of Aryabhatta, the first India satellite that was also launched successfully in 1975. And why it is known as Aryabhatta, you see, definitely it came from the name of that great ancient Indian astronomer, Aryabhatta. So that was a small 360 kg satellite. Basically, we had to depend on the rocket which was developed by Russia, USSR at that time, because we were not having our carrier rockets. But gradually it developed. Presently, what we have, the first satellite launching vehicle, the rockets which can launch a satellite, the first satellite launch vehicle which India indigenously developed was this SLV. And the project director of this SLV mission was APJ Abdul Kalam. Like that, we have come past a very long journey. We have developed our wonderful, the ISRO workhorses like Polar Satellite Launch Vehicle, PSLV, geosynchronous satellite launch vehicles, modern models, and we have such huge, wonderful, excellent facilities now. Now we have our rocket launching stations, we have our launching pads, we have our space, the places from where we can launch any kind of satellite and rockets. We have not only one that is in Tumba, we have two such stations. This is in Sriharikota, which is in Andhra Pradesh, and also we have in Tumba. So basically, as I was telling that although it started from minus or zero, presently we are standing in a place where we are one of the leaders in space science research. This is a very long story. I am just giving a very short glimpse of it. What type of satellites we are having nowadays? Thinking about that Aryabhatta, it was a very small and very novice kind of satellite. Also, for launching that satellite, we had to depend on the rockets which we hired from USSR. Now think about this satellite. I'm just showing one, INSAT. Now this INSAT satellite series is having a satellite. There are more than 30 satellites which has been launched in this series. And this is basically in the whole of South Pacific region, in the whole of Asia Pacific region, this is the most powerful and the most sophisticated communication satellite system. So you can see it is written, this is the largest domestic communication satellite system in the Asia Pacific region. And this all have been made indigenously inside India. Nothing, now we are not dependent on other countries. Instead, we earn revenue by selling data, by providing services from ISRO. So like this is going on. And these are some of the detailed salient features and characteristics of this INSAT series. However, apart from communication satellite, the glory is continuing. So this was the first Rohini satellite, which was launched, but gradually in every aspect for understanding almost the precipitation, the weather, forecasting of weather, sending education to remote places, understanding how water and all these things, how groundwater is behaving, what is the rainforest, how forests are behaving. For every time, for agricultural mapping, for everything, we use satellites nowadays. So these are some of the satellites which we use and which are all made in India. Even I can show you this picture as I was telling groundwater. You see, this is a satellite image from a Cartosat geographical geometry. This is telemetry and Cartosat mapping, which shows us how groundwater is distributed in our particular India in one particular time of an year. So all these things can be done since we are highly progressed in satellite technology, in space science technology, in astronomy. And apart from that, definitely there is telecommunication, there is remote sensing, there is disaster management. And apart from all these, there is security issue also. We have this particular satellite system known as RISAT. You can see it is used for so many aspects, these things, weather forecasting, disaster management, remote sensing, but it is also used for security, defense purpose. It is the satellite system which always goes on tracking the line of control in Jammu and Kashmir. So this surveillance of line of control in Jammu and Kashmir, for security purpose also, we are using satellites. This all has happened because of the huge development of space technology within I can say within a span of only 50 years. That is a miraculous, that is a unbelievable achievement, I can guarantee you, my friends. I was talking about the birth of ISRO from a small village near Trivandrum, and which is still now a fishing village, which was not having any proper road, any map, any facility almost. Presently, and that was only 50 years ago. And presently, ISRO has centers almost everywhere in India. It is having one of the most fantastic networks of satellites, technological components, spacecrafts, remote sensing devices across India. Why I am sitting in a jungle today, in a remote place? Believe me, my friends, if you come to Kavalur, you will understand it is really a remote place. But I am talking to you, all of you. You all are sitting in Bangalore city, and there is no interruption. Why it is happening like this, so smooth? Because we owe a lot to astronomy, space science, and those great leaders and great figures who helped us, who visioned that we have to develop very fast in space technology. So if we compare that birth of ISRO from a church to this picture, it always gives, at least it always gives me goosebumps. From within 50 years, not a single other space organization, research organization in the world has spread so drastically across the country. This has been done by ISRO. So I really have to thank all of you. And if you want to read further, my friends, you can specifically about India's journey to space. If you want to read further, I can suggest you these two books. Both are extremely wonderful books. So this second book actually tells how India's space journey began and how we have reached up to this much. It's a big book, more than 700 pages. But I can assure that if you go on reading this book, definitely you will understand how step by step, starting from zero or maybe minus, we have come to this stage. And many can ask us, many can ask you also, okay, ISRO is sending rockets to moon, Mars, all these things, doing good works, that is good. But what type of help every person of India is getting from ISRO's initiatives? This is the book. Read this book. Please read this book, Touching Lives. Each and every human being staying in India is getting some benefit because ISRO has done some good works in space technology. Why I am telling this? You have to read this book, Touching Lives. So, yes, if I am focusing on now some of the major achievements of ISRO, considering the astronomical missions, then definitely I was in college during that time. I was doing my BTech. I remember these days, Chandrayaan-1, the first successful mission of India to moon in 2008. And gradually, it was the first actually mission with the help of some other instruments coming from NASA. We were able to discover that moon also has water molecules. So Moon Impact Probe, this particular instrument was a part of Chandrayaan which actually touched moon. It was not a soft landing, it just hit moon, but that was the first time India became a part of that company and champion company where very few countries in the world have actually placed some object in moon. That was in 2008. After that, it was 2013 and 2014 specifically, when India became the first country in the world who successfully sent a maiden mission to Mars and achieved success. It is extremely difficult to send a mission to Mars, and no country till now has achieved or has been able to successfully send a Mars mission within first attempt. India did it in 2014. We ultimately came on. Presently, we have so many other satellites also, like we are studying Sun using Aditya L1. We are studying far away X-ray binaries and black holes using XPOSat. And most fascinating is definitely the recently most fascinating is the Chandrayaan-3, which actually was launched in 2022 or at the end time, and in 2000, I guess 2023. And in 2023 August, it landed. A part of this Chandrayaan landed softly, successfully on Moon, again creating history for ISRO and India. So these are some of the very, very fascinating and definitely most amazing, or I can say rather very important achievements, not only from India's point of view, but also from world sustainable development or economic point of view from the world, where India has shown that, yes, we are capable of making our own satellites, our own missions, our own spacecrafts. We are capable to design such satellites which can go to so far away places. So we are capable of doing good work, good job, good research. So this is where India is now going on, and why we are doing all these things, obviously for knowledge, obviously for the development of humanity, for the development of our country. And for this purpose, we also have this particular satellite, or this particular, basically, I will say, observatory. So this is India's first astronomy observatory, which is in space. This is known as AstroSat. It was launched in 2015, and till now it is working. So basically, it was launched in 2015. Till now, it is working. It has 5 instruments inside it, mainly 5 types of instruments for watching the UV radiation coming from astronomical objects, also watching the X-ray radiation coming from different astronomical objects. So this is how India is going on. There are so many other plans which are in our mind, which is going on with ISRO, with different institutes. And I hope that you all who are now young, who are now studying in different places, I hope that you all are going to become the next powerhouses, the next workhorses for our India. Please come forward, because our world, our universe is very, 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 very big. There are so many things we have to know, my friends. Till now, whatever we know about astronomy is very, very little compared to the universe. Why I am telling this? To give a basic idea why I am telling this, that we know very, very less about astronomy. I have shown 2 pictures. One picture is this. This is a comparative picture. You see, this is the full moon, and this particular rectangular field, it is a picture of one part of the sky. How big part of the sky? Not the whole sky. It is just 1 degree by 1 degree. This particular frame, rectangular frame covers only 1 degree by 1 degree of the sky. If any one of you want to draw a 1 degree angle through your protector or through your compass, I know that is very, very difficult. 1 degree is very small, but this is a picture of the sky taken by Hubble Space Telescope. Now, this length and breadth of this, the area of this picture is 1 degree by 1 degree, very small. In that picture, what we can see very far away stars, maybe galaxies. And we also see many places in this picture which is vacant, which is dark, which is looking like void. Nothing is there. So you see what Hubble telescope was told: focus your telescope mirror or cameras to one such very faint, very apparently looking dark place. And this was the place, this is known as extreme deep field of Hubble. So this is the place where Hubble focused its camera. And this can only be done, my friends, by Hubble, because it's in space. As I have told, is the most sophisticated instrument developed by humanity is the Hubble Space Telescope. After that, James Webb Space Telescope, like this. So it can do it. So what it did for 23 days, staying in space, it exposed its camera to this particular place. And the area of this whole picture is only 1 degree by 1 degree. And this picture was taken in a frame of 1 minute by 1 minute. The amount of space which you have at the top of your safety pin, the amount of space which you have at the top of your safety pin, that much small amount of space which is looking dark in the sky, Hubble Space Telescope was able to capture a vivid picture of that area. That's very small, so-called small dark void space. What we found we found this. That so-called blank space, so far away, so small looking, is consisting of 5,500 galaxies. My friends, please try to understand. These are not stars, these are galaxies. Each of these galaxies is containing maybe more than 500 crore, 10,000 crore, 20,000 crore stars. And in this huge universe, among millions and billions of such galaxies, our Milky Way is one such galaxy containing more than 10,000 crore stars. One star is our sun. We are basically very, very small. And the universe is very, 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 very big. I have shown this picture. I generally show this picture just to give an idea how big our universe is. So even in this particular picture, you see, this is a 1 minute by 1 minute frame. In that small area also we are watching, there are so many dark places. Now, if we have another telescope like James Webb Space Telescope, which can focus to any such dark place and take a small image and a vivid image of that place also, much smaller frame, maybe 1 second by 1 second or 10 seconds by 10 seconds. So this is looking like dark, but we know the answer what we will get. We will again get thousands of galaxies. So this is why we have to study astronomy. We have to move forward with space science. We have to study space science because humanity, from the birth of their first awakening, humanity has developed tremendously, and mostly because depending on the knowledge developed from or gained from astronomy and space science. The sky is the bestest friend of humanity forever. That's why I would like to suggest all of you, it is my request, please help us like astronomers. We are very less, astronomers are very less, space scientists are very less in the world. If you are interested in space science and astronomy, please come forward. Please come forward and be a part of this space science and astronomy community. I would like to stop here, and I feel already 1 hour is over. I will stop here and I will be happy to take questions from all of you. If you have any doubt, any comment, any question, please feel free to ask. And again, thanks to all of you. Thank you everyone for this wonderful opportunity. And thanks to all of you for coming here today and attending this talk. Thanks, everyone.
So thank you, Gauravji, for a very informative talk. I think there were some real gems of information within the talk that we enjoyed very much. So do any of you have any questions?
Thank you. Thank you.
Some of our students had to leave for a classroom, so had to leave for a class. Yeah. So we have one question here.
Yeah.
Sir, how to get into IIA?
Oh, okay. Wonderful question, my friend. Okay, let me share my screen again. Okay, let me share my screen and I will show you this. So basically, you have to go through something known as JIS, this thing. Joint entrance screening test. So let me share my screen. Okay, are you all people reading in master's degree, or can I know in which area you are all studying? Are you all bachelor's degree or master's degree, whatever you are? So basically, if you are in bachelor's degree or master's degree, yeah, tell me.
11th and 12th students.
11, 12.
They are
Okay.
11th and 12th students.
Okay. So you are in high school students. So my friends, after your 11th and 12th is done, you have to ultimately take physics. Take physics as your guide. So physics is the main guide through which you can go. So you have to do graduation using physics. First, you have to do graduation, that is bachelor's degree. After that, master's degree. So you can go to any good university or colleges for your master's degree. And
1 second.
master's degree in either physics or astrophysics or astronomy. And after that, you are in a right place. Now you have to give some particular exams for getting into PhD. See, astronomy, astrophysics is basically a hardcore academic area, academic subject. So you can become a scientist, you can become an astronomer if you gain PhD in astronomy and astrophysics. So for getting astronomy and astrophysics for PhD purpose, definitely IIA has that facility. Apart from IIA, there are so many institutes. You go to this particular website. So this is the exam, Joint Entrance Screening Test, or JEST is the exam. If you want to take PhD in astronomy and astrophysics, you have to give this exam, JEST, either JEST or UGC NET, National Eligibility Test, UGC NET. So if you go to this homepage of JEST and click here, participating institutes, you see which are the institutes, as I was telling, ARIES, all these IIA, Indian Institute of Astrophysics, IISc, ISER, there are some IITs also, IIST, Indian Institute of Space Science and Technology, IUCA, NCRA, all astronomy related institutes, they generally consider this either NET exam marks or JEST exam marks. So you have to clear this JEST or NET with more than 95 percentile, and then you will be called for interview in any of these institutes. So you can start gradually preparing which are the institutes in India which is offering astronomy research. These are all top class national level institutes. Very easy, go to this particular place, particular website, and see which are the institutes who are offering astronomy and astrophysics. Go to those institute websites, just click here, go to their website and see what is the eligibility criteria. So your question is about IIA. I am going to IIA. Let's see. So this is IIA website. Now you search here, just search what type of research they do, what are the projects they do, who all are there, faculties, postdocs. Come to these opportunities. Come to these opportunities, and now you see graduate studies, PhD program. Just open this. You see everything is written here. Everything you will get here. So if you want to do PhD, this is a full-time program. What type of work you have to do, what is the, everything you will see here. What are the scholarships you will get, everything is given here. So basically, yes, everything is here. If you want to do, if you are going to engineering, and after engineering, you want to do a particular program known as Integrated MTech PhD in Astronomical Instrumentation. That is also offered by IIA and ARIES. You can go there and ultimately see what type of work you can do, what is the eligibility criteria, everything will be there. So this is the eligibility criteria for PhD program. If you go, click here, eligibility criteria. So this is IIA. We have collaboration with three universities. One is Pondicherry University. So if you are getting PhD in astronomy, this is the qualification. So MSc or integrated MSc with or ABM Tech in these subjects, and definitely you should have a valid NET score or JEST score or GATE score with 95 percentile and above. And this is the age limit, so we have to follow that because since we are belonging to an institute under DST, so accordingly you can prepare yourself. Likewise, so since you are all in high school level, definitely study your subjects very well, specifically science subjects, but do not please neglect other subjects because then your marks will go down overall. Please take care of your all the subjects as much as possible. You focus on your studies and try to understand, try to know deeper and deeper about the subjects, specifically science. Now, when you go to graduation and post-graduation, then gradually you can decide if I am interested in astrophysics and if I want to go to IIA or IUCA or any of these premium institute. These are, so you just go to their website and see what is the qualification necessary and prepare accordingly. So this is how you can definitely come to IIA. Yeah.
We have one more question here.
Yeah.
Sir, my question is like the way you have explained about the qualifications to enter IAA or any other institutes.
Yes.
Why then why are we forced to take up JEE or any other competitive exams in 11th or 12th if there is a way to go by JEST or any other higher exams?
Yeah, see, JEE you need to go to. See, if you want to go to IIST, you have to go for this JEE, IITs. If you want to go to, suppose this, through engineering background, if you want to go to astronomy, then you have to take this. Another aspect is, if you are focusing, see, there are people who will definitely try to take 2, 3 opportunities. Suppose if you are not getting a wonderful opportunity in a very good college in BSc level, but if you are cracking JEST or if you are cracking IIT or joint entrance and you are getting a good opportunity in an engineering college, maybe IITs, maybe NITs, ISERs, like that. So you are getting an engineering background in a very good university or college, but you are not getting a chance, suppose, in a very good university for BSc graduation. So you can now come through that path also, right? You can do your engineering and come through engineering to astronomy the same way I did. I come from an engineering background. I don't come from BSc, MSc background. I come from BTech, MTech background. So this is why it's
Oh.
like a, you have 2 options at present. So now if you are entering BTech or BE in a very good institute like IIT Mumbai, IIT Kharagpur, IIT Kanpur, IIT Indore, they are also having Department of Astronomy and Space. So now you can think,
Yeah.
okay, now if I want to go to astronomy and space through engineering background, that is also a possibility. So why
Sir,
not
how
to
much of
explore that? Yeah.
how much
Yeah.
of a difference will it make? Like going through a top premier institution right after 12th, or maybe through JEST exam or any
No,
other
GST exam you cannot
UGC
give.
net.
No, GST exam you cannot give before master's degree. After graduation only you are eligible to give GST.
I know, but
Yeah.
what advantage will it create if we go to a top institution like IITs or NITs right after 12th in order to get into ISRO or anywhere?
Definitely, see, I will not
No.
suggest about any particular added advantage, but if you are going, if you are very much focused that I only want to go to astronomy and astrophysics through engineering or through graduation, and you are going to suppose IIT Mumbai or IIT Kanpur, IIT Palakkad, IIT Indore, these 4 IITs are having top class, and IIT Tirupati. These 5 IITs are having top class astronomy research facility. So if you are very much determined that I have to take, I will become an astronomer in future, nothing else, then you will get definitely a good advantage. Because if you are doing your BTech from those IITs, you will be in an environment where you see astronomers, where astronomers are working with you people. You can take projects under them. So that is an added advantage. But if you are, instead of going to IITs or NITs, good NITs like NIT Rourkela, NIT Trichy, where astronomy is there, Department of Astronomy. So that is an added advantage. But if you are not going to those, going to some other IIT, and if you are determined that I will go to astronomy in future, then why not, instead of going to that IIT, you can come to a good university for taking BSc graduation in physics, like that. So that advantage you will get. Suppose you are coming to even any private university, good private university, which is premium for astrophysics research, like Christ University in Bangalore, QSAT, Cochin University of Science and Technology in Trivandrum, in Cochin actually. See, if you're going there and taking graduation and having the determination that I will become an astronomer, then there is a great advantage. Otherwise, you can go to any other path. So definitely try to focus that if I am determined about astronomy and if I want to go to IIT, then go to those IITs where astronomy department exists with prolific research. So from first day of your BTech, you are into that background. You are watching 20 students, 20, 30, 10 faculties on astronomy. Same advantage you can get if you come to Christ University for graduation in physics. Or if you come to Presidency University, Osmania University, like that. Or if you're going to IIST, that is also you need IIT. IIT cracking in JEE, IIT mains, advanced. So this is the added advantage. If you are focused that I would definitely go to that particular field, then choose the places where you can go. Then you will get definite advantage. Otherwise, if you are going to some other IIT where astronomy research is not the prime motto, then it's better to go to a university where astrophysics research is done. That is the thing. Yeah, that's what I am trying to see.
Hello, my name is Jishnu. May I ask any
Hi.
questions?
Yes,
Uh,
yes.
Is it true that whichever country has the most space technology is also considered the most powerful country?
Up to a certain level, we can say yes. Yes.
What
Space
is your
technology is,
opinion?
yeah.
Okay. What is your opinion on weapons in space or space warfare?
That will also develop. That is also developing actually. Yes,
That is
yes.
developing. Like
That is
how
also developing. Yeah.
interference with satellites, attacking satellites, so
Yes,
forth.
that is also developing. Since you see, we are human beings, na? So we are always into destroying our world. So as humanity has developed in science and technology, at the same time, different types of destruction kind of equipments that has also developed. So that will come. See, Einstein never told us, right? You use that equation for making atom bombs.
Yeah.
This is the thing. But we made it.
Yeah.
That will also come. Yeah.
Has there ever been an instance of a satellite being hacked by another country for warfare on any other day?
That is difficult. Actually, I am not sure, maybe because these are all classified means information kept by the government of the country. They might not reveal it. So I am not a I might not know about that. Whether that has been done or not, I don't know. Yeah.
Also, one more question.
Yeah.
How is the financial situation of astrophysicists and people who work in space technology? Is it a well-funded career? I mean,
Yeah,
lucrative.
it's a very lucrative career if you, as I was telling. So since this is an academic field, proper academic field, without doing PhD, postdoc, a good amount of long-term studies, you cannot get a very good job. Because only very good to good jobs only exist in this field. You cannot get a simple mediocre job. So for getting a faculty position, if you can think, if you want to become a faculty in some very premium institutes like IITs, NITs, IIA, IUCA, you have to go through that long process. So that if you go through that, if you can go through that, definitely any astronomer or any astrophysicist life, a job is lucrative because these are all top class jobs of India and obviously abroad. Yeah.
Thank you, sir. Mike, please.
Sir, I had a question.
I had.
If I had an opportunity to join a laboratory in India, is it better to join a like recently set up laboratory or an old laboratory like which was been made for years? Where is India providing more resources? Is it
No,
like
basically, so your question is very good. What I would suggest is, in which area you want to join, you have to yourself search through internet. Means you have to do some homework. Suppose there are 5 laboratories in that. Suppose you want to go to material science. Some work you want to do and learn in some laboratory in material science. So which are the what type of top class institutes and CSIR or laboratories are available in material science in India, who are old, who are new, and the type of work which you are offered, what type of means whether that particular laboratory which you were choosing the best is very good for that particular in that particular laboratory. That homework you have to do. So in case
it
of
depends
astronomy,
on whatever like mission I want or research I want to do.
yes, what type of area you are going in that particular area, which laboratory, whether it is old or new, which laboratory or which institute is having a better facility. That's why I told you go to those websites of institutes and see who are the people working, what type of work they are doing, what are their facilities available, what are the instruments they have, what type of research they are doing. So these are some things which will tell you previously. So if you see that there are, suppose a particular laboratory having only 4 faculties, but those 4 faculties are doing very good work. They are doing some recent works. Then you can choose, no problem in that. But instead of going to somewhere, there are 50 faculties, but they are not recently doing any, they are not actively doing any research or good work. So that homework you have to do. So after that, you apply accordingly to those laboratories where you want to go. That will help you. Yeah. Okay.
Thank you, sir.
Thank you. Hi.
Good evening, sir.
Good evening.
I just wanted to ask you that, like, I want to do aerospace engineering. Like, after that, like, how should I continue so that I go towards astronomy or astrophysics?
So in aerospace, see, there are, so you can just, again, you can search in internet, just see the colleges and universities offering aerospace engineering in India. Even if you want to go abroad, you have to give some exams, that also you search. Now, after aerospace engineering BTech, you can go for master's degree. So you have to decide if you are doing aerospace engineering, after that you want to become a space scientist or space engineer and get a job in organizations like NASA, ISRO, European Southern Observatory, European Space Agency, like that, or you want to go to astronomy. So basically, as you have seen in our IIA also, if you are an aerospace engineer, you can ultimately take integrated MTech PhD, or after MTech, you can take PhD in astronomy, astrophysics. So you can join that, but that you have to decide.
Like, as an aerospace engineer, like who has done like a degree in astronomy, will have a good scope out there.
Definitely, definitely. Yes, yes. Definitely will have. See, but you have to be sure. Means being an aerospace engineer, BTech, if you do BTech, if you do MTech, after that, if you do PhD in aerospace engineering, then if you say that I want a job in astronomy, that you will not get.
Okay.
You can understand that. Because see, if I am a bowler, if Mohammad Siraj wants that I want to do means opening batting, that he will not get. But he can do opening bowling. That is the thing. Like that. Or if Virat Kohli, whoever he is, if Virat Kohli tells that I will open the bowling, that he will not be allowed to do that. So if you are making your career in aerospace engineering, maybe till PhD, after that, if you say that I want to go for astronomy, I want to get a job as an astronomer, that you will not get. But if you are making yourself astronomer after maybe BTech in aerospace or maybe MTech in aerospace, after that you are doing PhD in astronomy or MTech PhD in astronomical instrumentation, after that you say that, okay, I want to now take a job in astronomical instrumentation and astronomy, that is available. That you can definitely apply.
So like an aerospace engineer will how, like, I actually want to enter like a rocket production, rocket designing. Like
that is absolutely aerospace engineering area.
Yeah.
Yeah.
So like if I want to work for like ISRO, like what should I do? Like
So after BTech also, there ISRO has certain types. So just look for ISRO exams in internet. So every year or once in 2 years or something like that, ISRO has their own exams for hiring engineers, hiring scientists, like that. So definitely, if you're a BTech, BE BTech in aerospace engineer, definitely you can appear to those exams. Just be focus on your aerospace engineering, read very properly. Because naturally ISRO is one of the premier organization of the world in space science. So they will only select the bests. So that way you have to, that is more tougher than IIT exam preparation. So yes. So if you are determined, then go ahead and just check.
Sir, my name is Anusha. I had a doubt regarding what are the different fields that you can go for under astronomy?
Yeah, wonderful. See, basically astronomy, astrophysics, this is, as I am telling, it's an academic field. So either you can become an astronomer, means a scientist. So after PhD postdoc, being a scientist, you can become a faculty, you can become a scientist at these premier institutes like this, or you can become a professor, means a teacher, professor, university professor. So there are universities, even there are IITs, NITs, there are places like IITs, NITs, universities, where astrophysics department is there, astrophysics is taught, physics and astrophysics. You can become a professor of that place. You can become an assistant professor, associate professor, means, so at that time you are doing teaching also, at the same time you are also doing research. So that is also possible. You can obviously, in our nowadays, gradually, privatization is also increasing. So there are so many private companies which are coming up, who is also making space science components, astronomy components for outreach purpose, for teaching purpose, even for ISRO, for making different components of rockets and everything. There are private companies which helps ISRO. One of that private company is Godrej. I don't know How many people know in India, Godrej is a premier company which helps in rocket development for ISRO. So if you are becoming an astronomer, astrophysicist, or a space engineer, and go to those such private companies and join as a engineer or a scientist, that is also available. So basically, the types of jobs will be all related to academics. Either you go as an engineer or a scientist, join a private company, or a professor, academic life, or a scientist. Now, in premier institutes like this, properly dedicated research institutes like IIA, we don't have any BSc, MSc student. We have students coming from PhD level, but ample amount of students for internships, for projects. They are coming from all over India, colleges, universities, during BSc time, during MSc time. That also we have to guide. Yeah. So this teaching and training and research, that will be your major component of life. And at the same time, up to a certain level, you outreach and motivating the next generation students. So this type of work only you can get if you are coming to astronomy field. And so
One
these are
more
the
thing.
things. Yeah.
Okay, I like maths. Don't get me wrong, I like maths, but I'm not good at it. And astronomy, it involves a lot of it. So is it all right? Is it if I go into that?
Yeah. That is a very good question. See, I am also not that good in maths. I understand myself. I am also not that good in maths. I knew this. So it's very good. I mean, see, you all are in class 11, 12. So at this time, when you are understanding, realizing that I am not good in maths, it's very, very good. So see, astronomy is divided into many parts. So if you want to go to theoretical astrophysics, like what Einstein did, yes, by mathematically he solved problems, theoretically understanding, and solved and sorted out some problems. So if you want to go to theoretical astrophysics or theoretical cosmology study, you have to be very good in maths. But if you're not good in maths, you can go to observational aspect. I am an observational astronomer. So I actually study stars. I look at the stars, study them by taking the information coming from stars, mainly spectra. Spectra and the brightness, information, image, taking the image of stars, taking the spectra of stars. We try to investigate, we try to understand what is the property of those stars, how those stars are behaving. Definitely, up to a certain level, basic mathematics, which you all are good at, basic mathematics you will understand. But you don't have to become Einstein, Newton, Stephen Hawking for understanding those things. So if you want to go to observational astronomy or experimental astronomy, in every aspect, mathematics is not that much in-depth required. It will be required if you go to theoretical astrophysics or theoretical cosmology or relativity studies. So as you grow up, means I will suggest any one of you who are interested to take astronomy and astrophysics, please try to search some books from internet, Amazon, astronomy and astrophysics books, popular science books, popular astronomy, popular physics books, and try to read about, collect it and read this about cosmology, about exoplanets, about solar system. So as you know more and more about different aspects of astronomy, different fields of astronomy, gradually you will understand, okay, if I am becoming more and more interested into studying the history of planets in observational way, I might not require that much of in-depth math knowledge. So now you can think for studying planetary science in India, where I have to go. After Netaji's, the best place is PRL, Physical Research Laboratory at Ahmedabad. So like that will come gradually. Yeah. So maybe in future, when I come to Mangalore, I would like to meet you all physically. I am also studied from Udupi, Manipal University. I have spent wonderful days at Manipal, cherishing days. Yeah. So that's how you try to progress. Yes. Thank you. Yeah.
We have one more question. One second.
Yeah, sure.
So you told about this one IIA where we can visit the observatories, right?
Yes.
But instead of IIA, like instead of that, is there anywhere in Mangalore where there are good observatories where we could go?
Yes, very nice question. Yes, see, I was focusing on the observatories by IIA since I belong from IIA. But apart from IIA, ARIES, Arjobhatta Research Institute of Observational Sciences, Nainital, they also have big observatories. Even the largest optical telescope of the Asia, it belongs to Aries. It is in India, near to Nainital. It is known as Devasthal Optical Telescope. So Aries is having their own observatory. Then there is this National Center for Radio Astrophysics. They have their radio observatory, one of the finest radio observatories and telescopes in the world. We are having in near to Pune. Then there is solar observatories. So the PRL, Physical Research Laboratory, they have infrared observatories in Rajasthan. So yes, mainly these 4 or 5 institutes are having their observatories.
Yeah,
So,
are there any good ones in Mangalore also? Like in Mangalore?
no, observatory, no, observatory is not there in Bangalore. Because see, Bangalore is a city which is near to sea. So near to sea, you cannot make an observatory because sky will not be clear.
If I can add on that, actually, here in CFAL, we have an observatory. So, I mean,
Okay, that is okay. I am talking about absolute professional observatories by top institutes. So small observatories like that, CFL and yeah, definitely you have. So that you can utilize for some, knowing the sky, understanding the sky, looking at the sky, how you can use a telescope, how the sky looks like. So definitely CFL can help you in these aspects. Small projects you can definitely do using observatories. But if you are talking about definitely professional, world-class professional facilities, observatories, that is only available by 4 institutes of India. So mainly in high altitude Himalayan regions or remotest places of India, like that. Yeah.
Thanks.
Yeah. Correct.
Okay. If any of the online speakers want to ask any questions, I open the stage for them. Online participants, if you want to ask any questions.
I guess they have left.
Let's just the chat box quickly. Okay, there are no questions in the chat box as well.
In the chat box, there is no question. Yeah.
Okay.
There are no questions in the YouTube chat box as well.
Oh, okay. That can
We
you...
have a question. I think after that we can end the talk. Is that fine? One last question.
Yeah. Can you ask the question to me? Because YouTube, I might not be able to check.
No, as of now, there are no questions on YouTube.
Oh, okay.
So just to get some clarity into the topic, what work do you do in a university or an observation deck, to be honest? What is the
Okay.
focus or objective?
What I do, right? So we are from a group. We are into the group of stellar spectroscopy. So we take the spectra of certain types of stars, which are very rare stars, and we try to understand how so there are so many stars. In front of those stars, there are gaseous or dusty disks. So these stellar disks, how these stellar disks behave, and what it tells us about the high temperature behavior of gaseous particles, that we try to understand by observational astronomy, by taking the spectra of certain stars, certain type of rare stars. So I am in the field of spectroscopic study of rare kind of stars to understand stellar gaseous disks, to understand the properties of stellar gaseous disks, which will ultimately, which actually we want to do that because it helps us to understand how gas particles behave at extreme temperature. So that type of experiment we cannot do in Earth. Gas particles in very high temperature, we cannot study in earthly based conditions. We have to take the help from stars. So basically, in one sentence, I can say we are a group. I belong to a group, the Indian group, which studies stellar gaseous disks using stellar spectroscopy, using spectrum of stars. That is what we focus into. Yeah.
We have one more question here.
Yeah.
Let me just turn this around. Yeah, go ahead.
So you have talked about the electronic warfare, the other guy was asking about. What do you think where India stands as in terms of budget we have or whatever the funds
very
we
good
receive?
question. Yeah. So
And,
see,
what do you think
in
in the coming
warfare,
10 years?
also India is one of the strongest defensive nation in the world. So since DRDO, they will not reveal everything related to war and all these things, since these are classified. But I can assure you, yes, definitely, India stands among one of the best defensive countries in the world. Even if I don't know whether you people have idea, we can destroy satellites which is 1,000 kilometer above our Earth if we suspect that that satellite is doing some nuisance, tracking our country and something like that.
Yeah, that has been done around 30 years ago by an F-15 and US F-15. But what do you think, like
Specifically India.
like b- in terms of in front of US or the USSR? I think in terms of the budget, we are very low.
No, my
So
friend, we are the only two, or most probably we are among the only three countries in the world who can destroy even a satellite, a spy satellite, which is 1,000 kilometers above the Earth's surface. No other country apart from USA, and we suspect China has that type of power at present in defense. We have that. We have tested that. That missiles has been successfully tested in 2019 and is successful now. Yes. So we are extremely powerful country in defense. But most probably China also has that. Since China, many things they don't reveal. So we cannot say that we are the only two countries. Most probably we are among only three countries who have this, anti-satellite technology missiles. No other country has this. Yes. This is one example I'm giving. But apart from that, missiles and all these things were extremely powerful country. India is one of the most powerful countries in defense at present in the world, among the first five. Yeah, this is the thing.
So, okay, do we have any other questions? We have taken too much of the speaker's time.
But it is good, right? So they are interested.
Yeah.
Yes.
It's a pleasure to have you, Gauravji.
Yeah, it was a pleasure to have you all. Maybe I will be visiting Bangalore, nearby sometime.
I hope so. We can go to Manipal together.
Definitely. Yes. Yeah, okay.
So once again, thank you very much for giving us this excellent talk. And at this point, I think we will thank our speaker and call it a day. Okay. Thank you, Gauravji.
Thank you. Yeah,
Of course.
thank you.
Yes, thank you. Thanks a lot.
Okay, good night. Yeah, thank you. Yeah.
Good
night. Oh.